All right, so here is the practice problem that we're doing, number 76. So it says nitrogen gas, or N2, because it's a diatomic, can be prepared by passing gaseous ammonia over solid copper oxide at high temperatures. The other products of the reaction are solid copper and water vapor. In a certain experiment, a reaction mixture containing 18.1 grams of ammonia and 90.4 grams of copper oxide yields 6.63 grams of nitrogen gas. Calculate the percent yield for this experiment. Okay, so that's what we're going to do. So the first thing that we do is we have to set up our equation. So we have to figure out what the reactants are. So it says, nitrogen gas can be prepared. So we know that that's going to be a product. So I'm going to draw my arrow. And so one of our products will be N2, and it says it's a gas. So we're going to do a little G right there. Okay, and so next it says it can be prepared by passing gaseous ammonia. And so ammonia is NH3, and it's gaseous, so gas. Okay, and then over solid copper oxide, so that's CuO, and that is also, or no, that's a solid. Okay, so those are the reactants. Okay, and then it says the other products of the reaction are solid copper, so Cu, and let's see, also it says water vapor, so it's plus H2O and then in a gaseous state. Okay, so that is our equation, and so we have to balance it. So first we take inventory, so nitrogen, hydrogen, copper, oxygen, and then we just put how many of those we have on each side. So nitrogen, there's 1. Hydrogen, we have 3. Copper, there's just 1. And oxygen, there's also just 1. And do the same thing on the other side. So over here we have 2. And let's see, hold on. Okay. Cu, there's 1. Oxygen, just 1. And hydrogen, we have 2. Okay, and so now we have to balance this. So to start off, let's figure out what is the same. So these two are the same. Cu is the same across, and then oxygen is the same across. Okay, and so we need to fix the nitrogen. So I'm going to put a coefficient of 2 here. And so now I mark this out and put 2. And that's going to change the hydrogen. So now we have 2 times 3 is 6. Okay, and so now 2, 6. Now we have to change this hydrogen over here. So 3 times 2 is 6. So I'm going to put a 3 there. Okay, and so mark out the 2. Now we have 6 because 3 times 2 is 6. Okay, so now these nitrogen and hydrogen are balanced. Okay, and so let's see here. Okay, Cu, three oxygen. Okay, now we have to put a 3 here. The plus needs to go over here. Now we need a 3 in front of this because this changed oxygen to 3, so I missed that. But okay, so now we have Cu3 and oxygen is 3. So the Cu also needs a 3 in front of it. Okay, so we have 2633, 2633. Okay, and so that is balanced now. Okay, and so there's something else that I forgot to add onto the equation. And so at the bottom of this question it says, in a certain experiment, a reaction mixture containing 18.1 grams of ammonia, 18.1 grams of ammonia, and 90.4 grams copper oxide. So that's 6.63 grams. And then it says 90.04 copper oxide. And then, yeah, those are all the numbers we're given. Okay, so moving on to the next step.